the dorsal diencephalic conduction system, DDCS. You won't believe me in how uncomfortable conditions am I right now, but let's try. So, the main function of the system is to relay information from cortex, especially prefrontal cortex, into brain stem, particularly midbrain, to some amyloidic groups. Because as you might know, brain stem, which is here, brain stem. This is a cross section of at a certain level of the brain stem. This is it is. And there we have some substantia nigra part compacta, which is dopaminergic, and some of the other stuff. It's difficult to see here, but there are some other nuclei which are responsible for production of serotonin, which is monoamine, if I'm not mistaken. Also, norepinephrine, which is also important, dopamine, and acetylcholine. Basically, this is a huge and one of the most important function of midbrain. And I mean that these chemicals are strongly and directly, and I would say profoundly, modulate our prefrontal cortex. Without it, we literally won't exist. This is how important it is. And this system is strongly determines their function. So basically, this is feedback or something into the system from prefrontal cortex into these very important structures. And so how this works. So basically, main inputs are from septal nuclei, dorsal anterior cingulate cortex, lateral hypothalamus, basal ganglia, some parts of it, I don't know which ones, preoptic area, and diagonal band of Broca probably also. It is carried through a very, very teeny, small tract, white matter tract, which called stria medullaris. Stria medullaris. This is the main function of stria medullaris, because if you could see it before on a real thalamus, you could be wonder, like, what's the function of this small teeny tract? It is literally on top of thalamus. We can imagine here thalamus, and it is somewhere on top, more on the medial part. On the medial part, it collects all of the information from all of this, some of the cortical region and some of the subcortical structures, which are closer to the front of our brain. It is conveyed through stria medullaris, and the main input is medial and lateral habenula. Habenula is a very small region which is located on top, at the back top part of the thalamus. Basically, if we will see at the thalamus, this is a top part of the thalamus. We're literally looking on a top part of the thalamus. So it is somewhere here. This is right thalamus. There is supposed to be left one, and this kind of in the middle on the posterior part, somewhere here. Like medial habenula, lateral habenula, there is pineal gland, and there are some of the other corresponding structures. They are somehow interconnected, but habenula is somewhere here. It is very small, but turns out so important one. So medial habenula and lateral habenula, and then it's actually fueled by substance P neurons and acetylcholine neurons. I don't remember exactly how it is distributed here, but it is somewhere here. And then medial habenula sends projections into interpeduncular nucleus. What does it mean? So let me show you. Maybe not. Maybe I don't know how it. Actually, no, I can't try. So this is, again, this is bottom part of our brain. This is cross section of midbrain, and there are some peduncles, which are white matter tracts. This is here, and here we literally have supposed to have interpeduncular nucleus, because interpeduncular, again, as you can see, there are substantia nigra, and somewhere deeper there is also serotonergic centers. A little bit lower there is noradrenergic centers and acetylcholinergic centers. And I mean that medial habenula sends projections into this interpeduncular nucleus, which is kind of early. It is also GABAergic neurons, and then these GABAergic neurons project to some of these structures, such as substantia nigra and some of the others. I cannot say exactly because it's very complex, but it is how it works. Basically, the main function of this nucleus is kind of relay. It receives input again from medial habenula, and then it kind of modulates some of these monoaminergic centers. So there it is. It is going here, and it is going into dorsal raphe which dorsal raphe which is responsible for serotonin production, locus coeruleus, which is responsible for norepinephrine secretion, and as you can see, it probably inhibits it. It probably inhibits it because it's GABAergic. And it also might send some projections into some of the other acetylcholinergic centers, such as lateral dorsal tegmental nucleus, maybe, or they are basically two two nuclei responsible for that. I don't remember exactly, but this is the main function of that. And lateral habenula, which is glutamatergic, which is excitatory neurotransmitter. It sends projections directly to these monoaminergic centers, such as again lateral dorsal tegmental nucleus, mm, dorsal raphe nucleus, and we can imagine like actually no wait I'm a little bit confused. VTA. Wait, VTA is responsible for dopamine production, definitely. So you got my idea. Basically, monoaminergic centers, and water habenula sends direct projection to that, no matter where exactly, but it is regulates monoaminergic tone for our prefrontal cortex, and also a white matter tract which connects habenula with all of these centers is fasciculus retroflexus or retroflexus. So let's try to read and review some of that stuff. Uh, Lateral habenula. Neurons in the lateral habenula are reward negative as they are activated by stimuli associated with unpleasant events, the absence of the reward or the presence of a punishment, especially when this is unpredictable. Both the lateral and medial habenula show reduced volume in those people with depression. DDCS, which is dorsal diencephalic conduction system, is a pathway that transmits information from cognitive emotional forebrain areas. After forming a single unidirectional tract, these fibers project to the habenula, which in turn projects down through the fasciculus retroflexus, influencing midbrain monoaminergic centers. Through these systems, the frontal limbic areas can influence midbrain and whole brain monoaminergic tone. The SM, Stria medullaris, is a white matter epithalamic tract. It emerges just caudal to the AC, anterior comitia probably, anterior comitia, as a solitary tract that arches, arches, both dorsally and caudally over the interthalamic adhesion. In general, habenula activation reduces monoaminergic output. The habenula has been implicated in aversive decision making, reward pathways, mood, and pain. Well, oh my goodness, I'm tired. The medial habenula is also one of the strongest expression sites for mu opioid receptors, which mediate analgesic and reward properties of opiates. Well, and in the peduncular nucleus is an unpaired ovoid cell group at the base of the midbrain tegmentum, lies between the cerebral peduncles. The IPN is primarily GABAergic and contains at least two neuron clusters of different morphologies. This region is subdivided into 7 paired and unpaired subnuclei. The major input to the IPN arrives via the fasciculus retroflexus from the medial habenula. This pathway presents the IPN with several excitatory neurotransmitters, including acetylcholine and substance P. Other brain regions that project to the IPN include nucleus of diagonal band of Broca, the dorsal tegmentum, the raphe nuclei, the central gray, and the locus soiurus. Such a difficult name. The IPN. The IPN is felt to have broad inhibitory effects on many brain regions. So that's it. Maybe I should record it in this way. Oh my goodness, I'm so strange. Anyway, thank you for your attention, and this is a very interesting system. You can learn it on its own. Actually, to the best of my memory, so to speak, this has actually very interesting subdivisions. There are literally so many subdivisions. Really, it is such a small, teeny structure, and there's some of the details to it. You really can find in internet some diagrams which will represent the subdivisions of the human habenula. So appreciate your habenula.